Hello and welcome back to Blackbird. This is Venkat, and in this video, we will be talking about methods and we'll take a closer look into overloading of methods, understanding access control, and use of static and final keywords in our class. We'll also learn about something known as Var-args, variable length arguments inside of a method as a parameter. We'll learn about how exactly we can pass objects as parameters to methods and so on in this particular video. So I hope you stay till the end and learn about something new in this video. Talking about methods, it's a really large topic, and dedicating a video was important to this one. Basically, methods are similar to functions or something that performs a task. In functional programming, the use of methods is really something which is prevalent. And in some sort of functional programming playlist, we'll discuss actually what are the several types of methods that exist, like pure and impure methods and all. But in all, a method is an enclosed set of statements, a block of statements that performs some task. Now, if you talk about the syntax of a method, well, we have written methods multiple times, public static void main. That's also a type of method. So the syntax of a method would look something like this. It begins with a access specifier. Then there is a return type. And after that, there is the name of the method, followed by a parameter list here within the braces, like round brackets. Okay, and this section of the code in this part goes the body of the method. So we already know that what are legal identifiers with which we can have any kind of a name inside of a class. A method name is also an identifier. In a case where you'll have to basically two cases when you are making a method. You'll have the first case when you don't have to return anything. You just perform a task. And in that case, this return type would be specified as void, clearly mentioning to the compiler that there is basically no return type for this particular method. And there will be a case where you return something, and basically in that kind of a situation you can basically return every kind of a data type, like whatever this particular method wants to return, or whatever you make it to return. Let's say that I want to return a string, so I'll write here the string class. If I want to return an integer, I'll write int. If I want to return an object, I'll write object with a capital O. In that case, you can write like any kind of data types that you are going to return from the method. Okay. You might be wondering what is a parameter list, because as far as now we just have this one thing, that is string array args in as a parameter in the main method. But then what exactly is a parameter list? Let us talk about it. So it's nothing but a list of variables and data types separated by commas. So if I have to write its definition, it is a list of types and identifier pair separated by commas. So I can really write, let's say I have this method which says that it has to return the sum of two numbers. So I'll write public int sum, write int a comma int b, and then basically what I'll do is I'll return a plus b. Okay. If you're a beginner, you can really enclose this within a pair of round brackets, but it's okay. I mean, since there is just one expression that you're returning and both of these operands are of type integer, the sum that would exist would also be an integer as well, and therefore you don't need to specify or store this in any kind of a variable. Now this right here, int a comma int b, is the formal parameter list. Now there are something known as formal parameters and actual parameters. This right here is a formal parameter list. Okay, and the one Like let's say that I want to execute this method, so I'll basically create a object of that particular class and all of it, and then I'll, let's say, access it with this obj.sum, and then here I'll specify the values for these two, like for the parameters. Let's say I say 5 and 10. This right here is the actual parameter list. Okay, it's called an actual parameter list. Please excuse me for my handwriting and the background noise. I don't suppose things to go wrong about this, but cannot avoid it. My area, it's, I mean, it's a proactive area, I'd say. So yeah, this is an actual parameter list, and when we are actually calling it from the main method or from any other method or invoking this method sum, what it does is it passes these values, or if you have any variables storing these kind of values, to these formal parameters, which would then be used within the scope of this sum method. That's all about parameter list that you should know about. That's how you actually define a parameter list, and you actually define a method. Now let us do something. Let us have something in contrast where we'll write this public int sum, but we won't return something. Okay. So in case that let's say that I want to accept two variables in the former parameter list of the method sum, and then I want to print the sum of those two numbers, or like sum of those two variables, directly to the console. So in that case, you don't have to return anything. And contrasting to that, what I told you here, that your return type would vary, we'll see it right here now. So since I have nothing to return, I'll write a void and then sum int a, int b. And here inside the body, I'll basically print sum is equals plus a plus b. Now here I actually give braces because I want this particular operation to be executed before it concatenates with this. Otherwise, what output you would get is something very different, and it would not make any kind of a sense. I'll talk about it when we'll discuss a OCAGP question. But for now, let us keep it to the tutorial. And basically that's it. So, in contrast, you can see that I don't have to return anything, and hence I'm specifying this void. And if I have something to return, I specify int. Now, many people and many professors in your college or in your many teachers in your school would say that, if you're writing void, you can again write this return statement. Is it valid? Is it, will the class compile? Yes, it will compile, because this blank return statement won't make any sense if there is, the return type of this method is void, because basically you're returning nothing. It's just, as a used as a break statement to go out of the scope of this particular method. So yeah, this is correct. You can use this, but again, this particular thing is optional. It won't make any difference if you use or if you don't use it, if your return type is void. Okay. um, I think that'll be it for methods. We have already talked about constructors, which looks like a smart version of methods. Now let us talk about overloading of methods. This is something totally different, and here is where polymorphism comes into its form. Okay, but before that, let us just execute all of these code in the IDE. Let me get back to school projects, and I'll say methods dot method example. Let me enter the presentation mode. And by the way, a quick notice thing for you. I'll be soon launching a playlist on collections framework. So for all of those who are looking forward to learn about the collections in Java but find the topic really intriguing, you can check out that playlist, which will be uploaded soon, I suppose in within a week or two. So yeah, you can look into it. I hope you'll have a good experience in that. And it is really important that you do data structures of Java beforehand, because collections framework will actually require a slight basic knowledge of data structures like arrays and linked list, stacks, and queues. But it's okay if you don't have any kind of knowledge. That's on me. That's on me how good I'll teach you. I'll explain things from the basics till the advanced. They're not a big deal. Okay, so right now I want to have a main method, so I'll write psvm. Then let's say I'll have that particular method sum, where I'll have two parameters, int a and int b. This is the former parameter list. Then I'll basically print the sum. Oops. Sum is equals, and then enclosed within the braces, I'll have a plus b. And basically, then I'll invoke. Before invoking it, I'll just create a class of it so that I can access this sum method with the conjunction of this instance. So I'll write method example dot sum, and 5 comma 10 will do. Then we execute this program. The output is really predictable. It's 15. I don't expect to see any kind of mistakes in that. And yeah, sure, it is. Now, what I was talking about is removing these brackets. So if I remove the bracket, code functions really fine, but there is a logical error, and that is you get 510. Now, what happens here is it goes this way, or it goes this way around when it's going to print something. So firstly, it prints the string to the console, and then it sees that there is a plus symbol. So it means that there is something to concatenate it with. So if you look at this highlighted section, it prints sum is equals a space, and then it prints the value 5. And now the evaluation comes to this plus b. So since sum space is equals space, and then again 5 is a string, so what happens here, it basically concatenates it instead of making it a sum. And that is a really tricky part when it comes to certification exam questions, but it's all right, you have covered it in literally 40 seconds. Now what I was talking about again is having a return statement here. So you can see that return is marked as something grayish just because it is unnecessary. Since you already have the return type as void, you don't need to have this thing in your method anymore. Your method would definitely exit once all the statements are completed. But let's say if you have some statements beyond this, let's say if I try to print hello, this won't work because right here you have specified that you have actually told the compiler that the scope of this method should end after executing this return state, like after executing this print ln statement. And basically you should return to the caller function, which is in this case it is main. So once you have already returned to the main method, there is no scope of executing any other statements in this particular method sum. And exactly why we get an unreachable statement compilation error. And once we remove it, it's not a big deal, so it gets resolved. But if you're confident that you're only going to use the code and nobody is going to alter it, I should say you should not use return statements when the return type is void. But now let's say that I'm done with all of this and I want to print the output here in the main method. So what you do is you write a print statement, and you basically copy this thing here inside of the scope of print ln statement. Now there is some sort of an error. Yes, there is, because when you are trying to print something, it has to be either of the data types or a reference type, but it cannot be void. Even if it's null, it would get printed, but it should not be void, it shouldn't be empty. This method isn't returning anything, but if it would return something, only then it will print here and this compilation error would go away. So in order to do that, what I'll do is I'll replace this void keyword with the int keyword, and instead of printing it here in the sum, what I'll write is return a plus b. Once done, you see the error has already been resolved, and if now we execute this, we get the correct output, which is 15. All right, let's get back to our presentation and let us learn about overloading of methods. So when I talk about overloading, what comes first to your mind? Eating a lot of food? Getting burdened with a lot of homework? No, I mean, I understand you are some kind of a student if you are watching this tutorial. So overloading is a little different when we talk about programming languages. It's about having same method but performing different tasks based on the input type. So I think it sounds a little familiar if you try to relate it with your real life. Overloading can be understood as something known as polymorphism. a well-known object-oriented programming pillar. So a real-life polymorphism example would be you talking to your girl best friend and you, the same you, talking to your girlfriend. So, I mean, both will be different when we come to feelings, when we come to a lot of other factors, and statements, words that you use with them when talking to them. So basically, that is what overloading is. We have also learned about it a little when we were talking about polymorphism. Now, since method overloading is one of the ways that Java supports polymorphism, and if you have never used a language which has method overloading, uh, it would seem a little strange to you right now. But trust me, it's something really exciting, and you'll learn its applications a lot. I mean, you'll use it a lot when you'll have some sort of use cases in that way. So, what happens is when an overloaded method is invoked, what Java compiler does is it uses the type and the number of arguments as its guide for overloaded method resolution, like to decide or to determine which method to invoke, which overloaded method to invoke. So these two things, the type and or the number of arguments, they need to be different for a method having a same name, which means for an overloaded methods. Let us understand what is the difference between an argument and a parameter. This thing, the formal parameter list, is basically known as the parameters, and this particular thing, 5 or 10 and or any kind of variables inside of the caller method is known as arguments. And this is the method which is being called, which is being invoked. So a better word rather than caller would be the invoking method, and another word which would be suitable for the method which is being invoked is this. So arguments exist in the invoking method. Parameters exist in the invoked method. Okay, I hope that is clear. So basically, what the Java compiler looks for is the number of arguments. Now, this number of arguments is not the formal parameter list, mind you. It is the number of arguments here when you are actually invoking the method. Okay, and it's also based on the type of these arguments within the invoking method, and only then the compiler, based on this information, determines which overloaded method to invoke. Now let us see how exactly we can overload a method sum. So let's say we have a overloaded method, and our duty is to calculate sum of two variables differently based on their type. Okay. So what happens here is I have a sum method, a void sum method with parameters int a and int b. So basically this returns or this prints the integer sum. Okay, this is responsible for printing the integer sum. Now I have another method sum which is responsible to accept a pair of double type variables in order to return floating point sum. All right, this is our purpose for understanding how type can differentiate in between the choice of overloaded methods. Both of them don't have any return type, so it is void, and one prints a integer sum, the other prints a floating point sum. Okay, very fine. Let's jump to our IDE. Let us change it quickly. Let's say I'll have the same method for integer sum. Alright, integer sum is equals and plus within the pair of round brackets, I'll write a plus b. Now I'll have another method sum which accepts a double type, like which accepts a pair of double type variables. and it prints floating point sum is equals and then plus a plus b. I hope this is good enough. Now here in the main method, what I'm going to do is I'm going to invoke the sum method, but I don't know which sum method to invoke. So I'll basically do it this way. Let's say I have a integer argument 5 and 10. And at this point, if I run the program, I'm supposed to get an integer sum is equals 15, which I do. So you see, if we have given a int type, the compiler resolves to that particular sum method which has integer parameters. Okay. Now let's say I have 5.0 and 10.0. The compiler resolves to the second sum method, which is a floating point sum, just because I added this and made it a decimal or a floating point number, literal. So if I say double value 1 is equals 5.0, double value 2 is equals 10.0, and if I replace these values with val 1 and val 2, and again if I run it, I'll get the same thing. The floating point sum is 15. So this particular thing is the arguments. In the same number of arguments, you know in the same number of arguments, what we are getting to see that the data type of these arguments is helping what is it helping the compiler to distinguish between what overloaded version of sum to call. Okay. So this is how it is done based on the type. Now let us learn about how you'll do it based on the number of arguments. Okay. So let's say that we omit the floating point sum at this point, and we have a void sum that adds two integer numbers, int a and int b. Okay, that is two sum. I mean, you can understand it. It's just for adding two integer variables, and then I have another sum method with three integer parameters, three sum. So let us help the compiler distinguish between these two methods and actually see if it does or not. So here we are in our IDE. I'll remove this sum method. I'll change this to int because I want an int. I'll remove this point, and then I'll have public void sum int a, int b, int c, and then I'll simply print integer 3 sum is equals, and then I'll write a plus b plus c. Okay. Now I want to have another value, let's say 15. Okay. Now when I invoke or when I run this class with two arguments to the sum method, the compiler distinguishes and understands that there are two arguments. So I should resolve to this particular method which has two integer arguments. But if I add val3 here, then the compiler understands, oh no, wait, I should resolve to a particular overloaded version of the sum method which has three integer arguments. And exactly why, if I execute this code with three arguments, I get integer 3 sum is equals 30. But if I remove one argument, I get the first overloaded version of sum executed, which is 15. This is what overloading is all about. So this is one of the applications of polymorphism in Java. Now, in the same way, let us talk about what overloaded constructors can do. We have already learned about constructors in the previous video, so I don't think I need to repeat it. Just in case you forgot about it, you can pause this video, jump back to the previous one, and actually watch it, and then come back here to watch this one. Constructors and methods, I've been saying it since a long time that they are same but different. So in addition to overloading normal methods, you can actually overload constructors too, and in most cases you will actually need this. In the same way as overloading of method works, constructors can also be overloaded in the same method. Let's say that I have a class human, which has a constructor. This is the default constructor. It has no parameter list. Okay. But let's say I want to instantiate a human object. I mean, I'm sorry, but just for an example purpose, I want to have a human object with just their name. So this is a type of parameterized constructor where when I create an object of human class, and if let's say I only know their name, I can put it in this particular constructor in order to initialize their name. But let's say I also know about their weight. So what I'll do is I'll have a parameter string name and I also have a parameter double weight. So this is again a parameterized constructor, but this is an overloaded version. Okay, you see that it is varying in the type of argument, like in the number of arguments that we have that we will have here. Then again, let me say that I know a human who's I know his name, I know his weight, and I also know his height. So I want to instantiate a human being with all of these features. So this is another overloaded version of the human constructor. So you see there can be multiple constructors like this. So how exactly will the compiler determine which constructor to invoke? The compiler uses the same technique, it differentiates based on their type or the number of arguments that they have. And that is how overloaded constructors are also distinguished. Here we have been looking into the distinguish, like here we have been looking into the constructor, overloaded versions of the constructors, where the distinguishing factors is based on the number of arguments. But let's say it is based on type. In that case, we'll have a default constructor. Then we can have a constructor as a string name. We can also have a constructor saying that let's say that I just know the weight of the person, but I forgot to ask his name. So we can have a constructor based on that weight, and we can also have a constructor based on their height. So this can be an example of overloading of constructors based on their type. And in the same way as method overloading resolution is done by the compiler, constructors are no exception. They are also done in the same way by the compiler. Now that we have completed with overloading and all of its concepts, let us take a quick look at something known as passing objects as parameters. Now, all this while, what we have been doing is we have been playing around with um, the normal data types that we know about, the primitive data types that we know about. But we can also pass objects to methods. And a really great example here would be passing the string object inside of a method. So let's say that I have a method public void um, greet, and here I pass a object or a reference type which is string. So I say string name. Now I know you might have a question, string is really basic example of objects. Why are you using it? This is because most of the public here on my channel is or are beginners. So I'd love using this particular example rather than jumping into some really complex version of passing objects as parameters. So what I'll do is I'll print hello and name. I'll concatenate the name here. And now if we execute this, let us see what output we'll get. So I mean, it is really evident, but let's still do it. So what I'll do here is I'll have a public void greet with a parameter string name, and I'll print hello and then concatenate it here with the name. I'll remove all of these things, and what I'll do here is I'll create a string object. So I'll say string actual name is equals new string, and within the constructor of a string I'll pass a string. Let's say Keith. Okay, and then with the help of this instance, I'd invoke the greet method with this particular thing, this variable. We are getting a warning, new string is redundant. Yes, it is, but since we want to show that string is an object, we are using it for this example. And if we execute it, it's really obvious that I'll get this output. In the same way as strings, you can really pass arrays. So let's say I have an array in a new int of, basically, let's not just say new int, I'll just say 1 2 3 4 5. I mean 6, yeah, 5. And if I want to pass it to this greet method, I mean, let's just change this method and let's have another method here. Let's say display numbers, and I'll have a parameter int array. Okay, and what will this do? It'll say for each integer present in the array, I need to print it, and with, I mean, I want to have a comma separated display. Okay, so what I'll do is I'll have method example dot display numbers, and I'll pass this array to this particular method. Let me actually write down new int, because in that way it'll actually make things clear that no, this is an array, this is an object. So we are passing objects here. So now if we execute the code, this is something that we'll get: 1 2 3 4 5. Now let's say that I really want to mutate or like change some specific indexes here within the array, and then actually use it again in this main method. So instead of displaying numbers, let's say that I want to update array, and within that update array, what I want to do is for each element, for each okay, let's not say for each, let's say for index I beginning at 0, I less than array dot length, increment the value of I, and while this is true, what I'll do is I'll add 2, I mean, I'll add a value 1, or I'll increment a value I mean present at that specific index by 1. And then I want to print the array, so I'll say for each element present in the array, I want to simply print a comma separated list of it. Okay, and now if we call update array on this particular array instance, let us see the output. So we get 2 3 4 5 6, even though we had original array had 1 2 3 4 and 5. So this is something. Now let me ask something from you. What if I say that, since I have passed this particular array in integer array instance to the update array method, and we have successfully done everything here at this point, we have also got our output, and I'm expecting that there is no kind of change that has been made in the array. Okay, but now what I want to do is I want to use this particular array here in my class, which is method example, and I want to see whether all the values in it are intact or not. So in that case, what I'll say is for each value in the variable array, I want to print a comma separated list, just in order to check whether there is any kind of change in the values that has taken place if I have updated the array. So if I execute this, oops, I forgot to separate it with a print statement. Okay, so if I execute this, I see that I had passed an array of integers 1 2 3 4 and 5 to the update array method. It has done some operations, and it was supposed to print all those operated values. Successfully it has done that, and then after this statement has been executed, it has returned to the invoking method, which is the main method, where we are printing again in order to check if there is any kind of mutation or update that has been done or not. But what I'm surprised at is the fact that the values of the original array has been altered. How is it possible? We are under the impression that whatever actual parameter we pass here, to the method, it's basically copied. I mean, it's supposed to be copied and then used, within the scope of this method. That is how things work. Since Java is a pass by value, or like call by value, where the values within the actual parameters get copied to the formal parameters, which then is used by the or within the scope of the methods. So let me tell you one thing. You are absolutely right about it if you are having this question in your mind. But here's the twist. Many people talk about this as pass by reference or call by reference. But Java is strictly pass by value. And here's how. So let us put a new topic, pass by value or reference. So what happens in pass by value and pass by reference? These are two different things. Okay. So let me just quickly write down whatever we wrote there. So I'll have a public static void main and some multiple code. I'll say that I have an array is new int of 1, 2, 3, 4, 5. Alright, and let's say I already have the instance created here. I'm not writing all of that. So I'll say obj dot update array. I'll pass this here. Alright, and in the update array, we'll have array array by the parameter. What it does, like what updation is being done here is, we are incrementing all values by one. Okay, so that code is being written here. And now in the same way we have, in the main method, let's say I have a primitive type int b, a is 5, b is 10, semicolon, and I call on this obj dot sum, a comma b, and I have a sum int a int b. Okay, let me just skip all of this part, and here basically I print the sum a plus b. Okay, now let us understand what is pass or call by value. What happens here, when you invoke the sum method inside of the main method and pass a and b as the actual arguments or the actual parameters, what happens here is that the value that is stored here in the actual arguments gets copied to the formal parameter list. So what the compiler does in case of pass by value is to copy the value of an argument into the formal parameters. Okay, what it does is it copies the value of an argument into the formal parameter. So that is why when you write a is 5, b is 10, and then pass a and b as arguments to the method sum, here a stores 5 and b stores 10, and thereby when you try to print, you get 5 plus 10, that is 15. And that is how, I mean, pass by value works. So as I told you, Java is strictly pass by value or call by value. And this is a fact. This isn't some sort of theory. But what happens in the case of passing objects as parameters to a method or to a subroutine, other name for method? Things change dramatically. But if you try to look deep within how object and memory management works in Java, you'll understand it. So, with this particular statement, let's go statement, one by one. What the Java compiler does is it creates an array of size 5, of length 5, and it stores 1, 2, 3, 4, and 5. And the variable array ARR basically stores the memory location for this particular array in the heap memory. Okay, and here are the indexes 0, 1, 2, 3, 4. Okay, now we pass it to the method as an argument. We pass it to the update array method, and here we have a integer type array. Now when we pass it, what happens is it passes by value. So the copy of the value of an argument is given to the formal parameter. So if you see, what ARR stores is a memory location, and when we pass this array object to the method update array, this memory location is then assigned to this particular formal parameter array, and hence both the variables point to the same memory location, and there is just one instance of the array. I hope you understand the situation. There are two pointers to the same memory location. I've explained this better in object-oriented programming video where we have discussed how, not in object-oriented programming, in classes and objects video where I've discussed how memory management works in Java. So basically here, there are two pointers to the same memory location, and thereby any change that you try to make from one pointer, from one reference variable, will automatically reflect on the memory location. Will affect on the array present on that memory location. And since both ARR and array reference variables are storing the same memory location, we are getting a mutated array if we are trying to print after this, print the elements present in ARR after this update array statement. So this effectively means that objects act as if they are passed to methods by the use of call by reference. Like changes to the object inside the method do affect the object used as an argument. And that is what people term as call by reference. But in reality, Java is actually strictly pass by value. So there are no two separate topics. If there is any kind of question that is Java pass by value or pass by reference, then it is strictly pass by value. Even the official documentation of Java, as of Java 11, it states that Java, when you pass objects as parameters to methods, it is called call by reference. But actually the internal mechanism is pass by value, because you are basically copying the like giving the copied memory location to a formal parameter, and this is what we call as pass by value or reference. Now that you have learned all of this, let us know about how will you return a reference type or an object from methods. So when it comes to returning objects, in the same way, like we have been seeing all programs where you have been returning int, you have been returning double, you have been returning a boolean. Now is the time that you return a string. So what happens here is basically, let's say that I want to let me jump back to the present to this point, and let me go to the greet array. So let's say that I don't want to print something here. I just want to return the greeting so that I can print it in the main method. So instead of having void, what I'll say is this particular method greets or returns a string greeting, and in that case I'll write hello plus name. I'll append it with the comma. That's how you basically return objects in Java. There's not much to learn about this. I mean, there is, but then you will need to, you know, you'll need it in certification exams. And so let's not dive that deep into understanding whether or not if there is any object that is created when I actually return this in the memory, and if the object is thereby garbage collected or not. So you'll all need this in certification exams, and I don't think you'll need it right now in this introductory course. Definitely, it's a good topic to talk about, but not in this video. You can also return object class like this, and to tell you, object is actually a class in Java. And, this is the parent class of basically all the classes that exist in Java. So you get a good documentation thing here. You can also learn it from this documentation. So yeah, let us move on and close this thing. um, I'll set the presentation mode, come back to method. So returning objects you have already seen. You can really you can also return an array. um, let's say you want to return an updated array. So what you'll do is you'll simply write that you want to return an int type array, and after processing it you can really write return array like this, and then you can use some other variable, let's say int updated, to store this returned array, and then you can print it in order to see the elements that are there. So if I execute this, I'll get 2 3 4 5 6. So things can go that way as well. So I don't think I need to tell anything more about returning objects. So what I'll do is we'll talk about the keyword static. Access control is something that we have already talked about in the previous video. So we won't talk about it right now. But if you still want a video, you can comment access control and I'll make a video on that. So static is a keyword in Java. Firstly, there would be times when you want to access a class member, just by the class name. You don't want to create a object or like an instance of that particular class and then access it. That is where static comes into play. So if you want to define a class member to be used independently of any object, independently of any instance, you use the static keyword. Or there is another use case of static keyword where if you want to access a class member before any of the objects are created, you use the static keyword. Okay, so it's the same. The best example of understanding the static keyword would be the main method that we have right here. So if I enter the presentation mode, I'll show you how it works. Now we actually use this static keyword here for the main method, and the reason why we use this is because we want that the main method gets executed before any objects are created in Java. So static keyword helps us doing that. Static can be applied to any class member to declare it a global member. We can use static with, you know, a key, like a variable as well. So I can say private static int sum is equals 90. So this is a global variable. Let me say some other variable because sum is already being used somewhere. So I'll say value is 90. So what this does is before any objects would be created, this particular variable value would be accessible just by the conjunction of method example and followed by the variable which is declared as static. In fact, the main method would also be accessible in the same way. You can just call method example.main. You don't even have to create any kind of an object for method example class. But there are some restrictions to it. And what are the restrictions? Let us learn about these restrictions that comes with the static keyword. So methods declared as static have these following restrictions. The first one is they can only directly call other static methods of their class. So you can only invoke other static members of the class. You cannot invoke or you cannot use any other non-static member of that particular class. So I'll give you an example of this one. Wait. In the main method, let's say that I want to, have this thing. I want to greet. I want to invoke this greet method just by using this method example and followed by that conjunction of the greet method. So if I do it like this and if I specify some parameter, there is an error that I'm getting. And the error is that non-static method greet cannot be referenced from a static context, which makes it really clear that you cannot access a non-static method from a static scope or a context. The other restriction that we have is we can only use other static members or variables of that particular class. You cannot access any instance variable. And I have talked about instance and global variables very clearly in classes and objects. So you should check out that video. And the third restriction, that is, you cannot use keywords like this or super inside of the static scope. You cannot use it. So the use of these keyword this and super is available only till non-static context. You cannot access them in a static scope. I hope I made. I think I made myself clear. Just like the way, this is something really interesting, and you'll love to know about this. People don't really talk about this that much. Um, just the way you use constructors to initialize instance variables, static class variables are initialized. I missed one I. Initialized within the static initializer. Now, what is static initializer, or what is static initialization block? What is it? So basically, let me just remove all of this code, and let me create some breathing space in my code. I don't have that. So let's say I have a variable named static int value, and I have another variable named static int value 2, both of integer type. I want to initialize them with some value. So I'll say static, and then I'll give a pair of braces. Within that, I'll say that value 2 is 10 and value 1 is 15. Oh, yeah, value 1 is 15. Now, what I'll do in this main method, I'll print the product of value 1 and value 2. When we execute this, you see that we get the value 150. And this is a static initialization block. Even if you place it after the main method, some people might say that, main method is after the initialization block. So, it's obvious that the top down approach would be followed. But no, you still get the same result, which is 150. So this tells us that static initialization block gets executed exactly once in your program when you run it, and it is executed before the main method is executed. So, if I try to give even, a stronger proof of it, static initialization block, and if I run this, you would see that static initialization block gets printed first and then the product of value 1 and value 2. So this is what static initialization block is. Now let's say that I want to access this value 1 and value 2 in some other class that I create. Okay, so let's say I have a class driver, and within that class I have a main method, and here I want to access the value 1 and value 2. So what I'll do is I'll print method example dot value 1 times method example dot value 2. As you can see, that I have not initialized or I have not instantiated this method example class, but still, if I run this particular driver code, I'll be able to access and get the value 150 printed. How is it possible? Okay, let me just remove this initialization block. So if I run it again, you'll be able to see that, I get this values printed pretty easily. But how is that possible? Let me write driver, and yeah. So if I execute it right now, you see that we get the output as driver 150. This is possible because this is made possible by the Java, because this is how you actually access static members of a particular class in Java. Now let us talk about the final keyword in Java. I won't be diving into a lot of details in this particular keyword, like about this particular keyword, because we'll be understanding it better in inheritance when we'll be discussing inheritance. But I'll still say what are the three uses of the final keyword. The first use is it is used to declare a variable as unmodifiable. So once you actually declare a keyword with the help of final keyword, you won't be able to change its value once assigned. The second use comes with method parameters, like you cannot override a final method, which is pretty obvious, but we'll learn about what overriding is in inheritance, and only then we'll discuss this point. And the third use case, it's is that for a local variable, it prevents the local variable from being assigned a value more than once. So in case of local variable, once you declare, like let's say you declare final int sum is equals 20, then and then you write sum is equals 30, you'll get a compilation error here at this point saying that sum is final and you cannot alter its value. So this is something that you cannot do after declaring a local variable final. So this is what final keyword does. Now here one thing that I want to say is when you declare a class member variable as final. So what happens here is you have two options to initialize the value of that particular final variable. The first option is to initialize on the fly, which is to initialize while declaring, which is also called dynamic initialization. And the other option is basically to use a constructor. Okay, so these are the two options when you make a class member variable as final. Now let us talk about something known as Var-args, variable length arguments, something which was introduced in Java 5 but is not that prevalent these days. Although it is considered to be a solution to overloading, but I don't think it is somewhere near to it. But we should still know about it. This is something new that you'll learn in this video, apart from memory management. So introduced in JDK 5, this feature was to replace the traditional method overloading feature, because it simplifies the creation of methods that need to take a variable number of arguments. Like let's say I have an example for this. Let's say that I want to have a method named sum that prints all the summation of all the arguments given to it. Okay, but I haven't specified how many arguments, and in that case the length of the arguments varies, and hence it is called variable length arguments. So this is like a hyphenated word. Variable length is together. Okay, don't take it for variable and then length and then arguments. No, it's not like that. It's variable number of arguments basically. And a method which takes a variable number of arguments is basically called variable arity method. I know that you have not heard this name, so please pay attention here. You'll learn something really interesting to flex in your school, college, or even to your lecturer. Huh. Situations that actually require a variable number of arguments to be passed to a method are not unusual. Like I just gave you an example, to have a method sum that prints the summation of all the arguments that are to be given to this particular method. So before JDK 5, if you were given a task to handle this, how you would do is basically there would have been two ways to do this. The first way would be, if the maximum number of arguments was small and known, then you could overload the method. And the second way was basically, to put an array in place of an, like in place of variable length arguments. So basically, this second method was consuming more memory than expected, because you basically had to put everything within an array and then pass it as a parameter, as a parameter to the method. But after JDK5, Java decided to have this variable arity methods, where with the use of a particular syntax you can achieve it. But what was that syntax? It was like this. It goes like this. You know, um, the syntax is you write everything exactly the same. So I say access specifiers, modifiers, then there is a return type, and then there is the name of the method. And here is the trick that comes in order to make this method variable arity method. So I write, let's say that I want to have all the arguments as integers, so I write int followed by ellipses, and then the name of that variable where we are going to store all the parameters generically. So I would say parameters, and after that we'll have the body, where we will be able to use this variable parameters as an array, mind that as an array. Now these ellipses that we have talked about, we have these are basically called ellipses. So they are like 1, 2, and 3 dots that you can do, like, and you can write that in your keyboard. And these are kind of separators that we have talked about in the first video of this playlist. Okay, and this is the official syntax. This is the var-arg, variable length argument syntax. Now when I have to actually use this method, let us try this in our IDE. I'll remove the rest of the code. um, yeah, and something from here. Oops, something from here. This video can actually go a little long, because we are discussing everything in so much detail that I don't think any of the videos on YouTube would have been discussing all of it in one go. And we are doing it, so please show some love to this video, like this video, and actually subscribe to the channel instead of just being a viewer, in order to get all the updates from this channel. So now getting back to the topic, I'll create a variable arity method, say public void sum. And just for one reason, let us say that it is a static method. you know I just want to don't instantiate this meta instance class back and forth again and again. Write sum, and then I want to have all the parameters as integer, and I'll write parameters. And within this particular method, what I want to do is for okay, firstly I need to have a variable sum is equals 0, initialized with the value 0. And then I'll say for each element present in the parameters array, I want that the accumulator sum accumulates the value. And at the end, what I'll do is I'll print the summation here. You might see that this variable arity method sum takes a variable argument, vararg, and this parameters we are this variable parameters we are using it as an array. How is that possible? Basically, it was done to bridge the differences, of actually having an array. So you don't have to create you know a array and then store all the variables within that array, the value within that array, and then pass it in the actual parameter list. So now if I had to invoke the sum method with any number of parameters, I can say 5, I can say 10, I can say 15, I can say 20. And you see that I just have one parameter here, but I can give a list of comma separated integers as an actual parameter list to the invoked method sum. And if I now try to execute this, the output that I'm going to get is the summation, which is 50. Pretty accurate. And like in the same way, I can have multiple values here, and there is basically no limit of it. You can have as many values as you want. You can even have variables which are being stored. I mean, variables which store these values separately and then pass the variables as actual arguments. Now, you might have a question that, let's say, I want to accept some other argument, I want to accept some other parameters as well to this sum method. Let's say I want to greet the person who is invoking this sum method and then print the summation. So can I do that? Yes, you can. But in that case, the variable length parameters should be at the end of the parameter, like of the formal parameter list. So I can write string name, and then I can write this variable length parameter, which is int and parameter. And here also I'll have to specify the name, which is Keith, and then the variable length uh, arguments. So, in this way I can really do like hello and then name, and basically then print the summation. So you get hello Keith, and then the summation is 300. So it can be done in this way. But let's say that you want to have this variable arity parameter in between. No, you cannot have that here, because that's not valid. So if I say string name 2, you'll get an error stating that var-arg parameter must be in the last of the list. The formal parameter list is being talked about. So there is one constraint that you need to remember, and let me mention it down here. Variable length parameter should be at the last of the formal parameter list. And you need to keep this in mind, because this is really important. There is one more restriction that you get to see, which is you can have only one variable length parameter for a variable arity method. Should keep these two things in mind, because these are really important. And questions in certification exams come from here, and people make mistakes and they lose their marks. Now you can also overload variable arity methods. So you can create multiple versions of the same method having variable length arguments. And Varargs method can also be overloaded by a non-Varargs method. For example, I mean, let me just specify here. Variable arity method can also be overloaded by a non-variable arity method. So let's say that here in this example, you have the same sum method, but you don't have this variable length parameter. Well, that is also considered as an overloading, and yes, that is absolutely fine to go with. But there are some sort of ambiguities that are associated with Var-args, and especially with overloading functionalities. So what is that ambiguity? What is that one condition where Var-arg fails? So, once upon a time, Byomkesh Bakshi was given this job to find out what is the ambiguity that exists within Varargs. And what he concluded in his papers was, let's say that he gave an example that if Venkat has public int sum, okay, and within this, with basically no parameters, that is what something to note. Basically, I write sum is equals, oh, I should have void here, not int, and then plus 5 plus 10. And then I have another version of the sum method, public void sum, which is basically a variable arity version. I say int three ellipses and then parameters. And then what I do is I find the summation and then print it. And within the main method, what I do is I give a call to the sum method. But the point being, I mean, okay, it's not a static, so let me write obj.sum. It is important, but otherwise you guys will take a clip of it and make a joke out of it. Okay, so yeah, if I invoke the sum method, the compiler is confused because you can basically have zero parameters and that will be also a valid variable arity method. But there is already a zero parameter method present here. So which one should the compiler choose? This one or this one? This particular thing is called ambiguity. And thereby, Byomkesh Bakshi concluded that this is an ambiguity and should not be henceforth used, in your programs. And thereby, if you actually have to use Var-args, you should have a defined purpose, or else there will be a conceptual flaw in your code. So this is the end for this particular video. I hope you have liked this video, and since it's a huge one, I don't think that you would have actually reached till the end of this video. So if you have actually reached, then give yourself a reward and comment down in the comment section that you have actually reached till the end of this video. Um, and we'll pin all the comments down there in the comment section, and you'll get a one-on-one interaction session which will be live streamed on YouTube if you actually do so. So thanks for watching, and in the next video we'll learn about inheritance. So stay tuned and subscribe to this channel. Thank you.